Imagine this, it's been about 30 years since NASA astronauts embarked on an immensely daring mission to save the Hubble Space Telescope. At the time, it was perhaps the most audacious endeavor scientists had ever conceived. Launched in 1990, Hubble had faulty optics that produced blurred images, but it was designed to be physically repaired by astronauts. Thanks to the brave efforts of those astronauts, Hubble was restored to full functionality, enabling it to capture some of the most iconic images of our universe. These images have not only fascinated the public but also provided invaluable data for scientists, leading to groundbreaking discoveries and a deeper understanding of the cosmos. Fast forward to today, and this legendary space telescope once again cries out for help. Unlike before, NASA now faces major financial troubles. The agency's budget has been stretched thin, with significant resources being funneled into other ambitious projects like the Artemis program, which aims to return humans to the Moon and eventually send astronauts to Mars. These grand endeavors, while groundbreaking, have left little room for additional expenses. The Artemis program, in particular, is an immense undertaking, requiring the development of new technologies, spacecraft, and infrastructure to support human missions to deep space. This has led to budget constraints for other projects, including the maintenance and servicing of existing space assets like the Hubble Space Telescope, but all hope is not lost. Enter SpaceX, NASA's reliable commercial partner, promising to save them from this predicament. SpaceX has a proven track record of innovative solutions and successful missions, making them an ideal partner in this critical endeavor. We'll discuss everything about this in today's episode of Tech Map. But before we dive in, a warm welcome to our new viewers. Don't forget to subscribe to the channel and hit the notification bell to stay up to date with the latest news from SpaceX and the world of space. Now, let's jump right into today's episode. Since its launch, Hubble, the world's premier visible light space observatory, has been sending back jaw-dropping images for 32 years. It orbits about 332 miles, 535 kilometers, above Earth, completing one orbit approximately every 95 minutes. The telescope has given us unprecedented views of the cosmos, capturing images of everything from our nearest celestial neighbors to the most distant galaxies. Hubble's mission has provided invaluable data that has reshaped our understanding of the universe. It has captured the birth and death of stars, the collision of galaxies, and even provided a glimpse into the formation of planets. Hubble's observations have helped answer some of the most fundamental questions about the nature of the universe, such as the rate of its expansion and the presence of dark matter and dark energy. However, space is a risky environment that can threaten any man-made object that stays there long enough. Hubble is no exception. Recently, it has been experiencing continuous incidents, putting its life in a state of uncertainty sooner than planned. On November 29, NASA announced that Hubble was in safe mode due to a problem with one of its 3 operational gyroscopes. These gyroscopes are critical for Hubble's ability to point accurately at its targets, ensuring the precision needed to capture clear images. The gyro first triggered a safe mode on November 19 with faulty readings. Controllers restored operations only to face issues again on November 21 and 23. Engineers are studying the problem, but it's unclear when science operations will resume. Hubble can operate with just a single gyro, but with some loss of productivity, such as the inability to perform certain solar system observations. The telescope originally had 6 gyros installed during the final shuttle servicing mission in 2009, but 3 have since malfunctioned. This reduction in the number of operational gyroscopes has significantly impacted Hubble's ability to perform its scientific missions. The telescope relies on these gyroscopes to maintain its orientation and stability while observing distant celestial objects. Without them, Hubble's precision and effectiveness are compromised, limiting its ability to gather high-quality data. NASA faces 2 major problems here. First, its budget. Despite being the richest space agency, NASA doesn't have the funds for a dedicated mission to service Hubble. The last servicing mission, with the shuttle and a crew of 7, cost around $900 million. Worse, there were political debates this fall about reducing the budget for the telescope in 2024. NASA is considering cutting budgets for its two largest space telescopes, Hubble and Chandra, due to larger reductions in astrophysical spending against the backdrop of the expensive Artemis program. NASA was hoping for an increase in its budget proposal for fiscal year 2024, requesting $93.3 million for Hubble and $68.7 million for Chandra, roughly consistent with previous years. Together, these amounts are a little over 10% of the total astrophysics budget. Second, Hubble was technically expected to be inoperable by now. Yet, it has so few equivalents that it's better to keep it operational. The scientific community continues to rely on Hubble's unique capabilities. Hubble has contributed to numerous groundbreaking discoveries and has been instrumental in advancing our knowledge of the universe. Its ability to observe distant galaxies, stars, and planetary systems with unparalleled clarity makes it an irreplaceable asset in the field of astronomy. NASA has invested massively in and now operates the James Webb Space Telescope, which promises to take our observations even further. The James Webb Telescope, set to be the successor to Hubble, will explore the universe in infrared light, providing new insights into the early universe, the formation of stars and galaxies, and the atmospheres of exoplanets. Meanwhile, the future Nancy Grace Roman Telescope is nearing completion. This new space observatory, named after NASA's first chief of astronomy, is designed to investigate dark energy, exoplanets, and other astrophysical phenomena with wide-field observations. The Roman telescope will complement the capabilities of both Hubble and James Webb, further enhancing our understanding of the cosmos. Even China is launching its own Hubble next year, showcasing the global interest and investment in space telescopes. Faced with annual calls to save Hubble or bring it back to Earth, NASA agreed last year to accept proposals for different types of service missions. This was a call to the private sector for innovative solutions, and that's where SpaceX comes in. NASA and SpaceX signed an unfunded Space Act agreement on September 22, 2022, to explore the viability of a SpaceX and Polaris program proposal to push Hubble into a higher orbit with the Dragon spacecraft at no cost to the government. This study, proposed by SpaceX and the Polaris program, aims to understand the technical constraints of servicing missions. It's a non-exclusive study, meaning other companies may propose similar research using different rockets or spacecraft. The investigation will take up to 6 months, collecting technical data from both Hubble and the Dragon mission to assess the feasibility of safely docking and maneuvering the telescope into a more stable orbit. Jared Isaacman, the billionaire backing the Polaris program of SpaceX's private astronaut missions, suggested that a Hubble mission could be the second of 3 planned Polaris missions. Isaacman, known for his philanthropic efforts and passion for space exploration, has a history of funding and participating in private space missions. His involvement brings not only financial resources but also a visionary approach to space exploration. For those unfamiliar, the Polaris program is a collaboration with SpaceX announced in 2022, set to conduct up to 3 human spaceflight missions to demonstrate new technologies. Its first mission, Polaris Dawn, is targeted for no earlier than late 2023, aiming to fly the Dragon spacecraft with 4 astronauts 870 miles above Earth, the highest since the Apollo missions. The third mission is scheduled to be the first human flight of SpaceX's Starship. Isaacman believes that a Hubble mission could extend its life by a decade and eventually bring the telescope back to Earth for museum display. He also suggested that modern gyroscopes and computers, now much smaller, could be used for repairs. This idea is based on the significant advancements in technology since Hubble's original components were designed and installed. However, not all experts share his enthusiasm. Crew Dragon lacks an airlock and a manipulator arm, and despite the mission being funded by Isaacman's own funds, NASA will still need to spend time and resources on its preparation and support, which is problematic given current budget constraints. The space community has its own views on Isaacman's proposal. Some speculate that the second Polaris mission will include a spacewalk, reminiscent of the 1993 mission when astronauts manually repaired Hubble during 5 spacewalks. These spacewalks, or extravehicular activities, EVAs, are highly complex operations requiring specialized training and equipment. The success of the 1993 mission demonstrated the feasibility of in-space repairs but also highlighted the challenges and risks involved. However, modern EVA suits and spacecraft engineering present several challenges. Suits might not be maneuverable enough for replacing gyroscope systems, and Crew Dragon's main engines, positioned around the docking adapter, complicate the process. Moreover, the technical intricacies involved in docking with Hubble, stabilizing the telescope, and conducting repairs in the vacuum of space are formidable challenges. A more likely scenario is a future NASA mission flying on a Starship, possibly docking a Crew Dragon to the Starship for safety, using a robotic arm to assist in repairs with NASA astronauts in new orbital EVA suits. The potential for robotic assistance and advanced EVA suits could significantly improve the chances of a successful mission. Robotic arms, similar to those used on the International Space Station, could provide the dexterity and precision needed for intricate repair tasks. Additionally, the development of new EVA suits designed for long-duration missions in deep space could enhance the safety and effectiveness of astronauts performing repairs. So, what do you think about the feasibility of NASA's solution to save the Hubble telescope? Let us know your thoughts in the comments below. The involvement of private sector companies like SpaceX in such high-stakes missions marks a new era of collaboration and innovation in space exploration, and that wraps it up for today's episode. Make sure you subscribe to the channel and turn on notifications so you don't miss any important space updates. Your support drives us to continue delivering high-quality content. Thank you, and we look forward to seeing you next time.